By the end of this video, you will be able to write data to the coils on the STM32 microcontroller with the Modbus TCP protocol. So, as always, I will be using the Nucleo F756ZG. You can also use any other microcontroller which supports Wi-Fi communication, but for now I'll be using on the STM32 because I will be using it in this series of Modbus TCP. I'm using the same code from the previous video. Go check it out if you haven't seen it. This is how the packet of writing one coil inside the memory looks like. So we have the transaction ID, protocol ID, and message length, as always. And then we have the address byte. Well, actually, the terminology is a little bit wrong here. It's actually the coil address, like the index of the coil. And here we have the value. If we want to write a 1 to the coil, we need to send FF and then 00. And if you want to reset it to write 0 to the coil, we have to set it both of the high byte and low byte to 0 in order to reset it. Okay, so this is the response as well. It basically looks the same. And let me show you the function, which basically will write the, let me show, actually the if statement, which will write data into the coil. So basically we have here, this is the whole code related to writing to the coil, and I'll pull this over here. Okay, and basically we are extracting the content of the buffer starting from index 8 to the response. It basically represents the coil address and the high byte meaning the coil content. So then we extract the coil position, and basically this is how it works. The master will send the coil index that it wants to write to, and it is not in byte address. It is actually the coil index, because the coil is only 1 bit wide. It will send, let's say, for instance, coil number 23, and if we have the coil number 23, basically 23 is equals 16 plus 7, so we have 2 bytes, and then the index 7, so this will be the coil that we're looking for, because the indexing in coil starts from right to left. So basically we have to go over 2 bytes, and then on the 7th byte, which basically on the 7th bit of the 3rd byte, will represent the 23rd coil. So this is how we will extract it. Basically we extract the byte address with /8, so basically we have to divide it by 8, and then we extract the bit position by saying modulus 8. For instance, in our case, as I said, 23 mod 8, it will be equal to 7, and 23 divided by 8, it will be equal to 3. Here, based on the content of the last 2 bits of the payload, we will either set the coil or we will reset it. If you send something else which is not equal to the values that we're basically looking for, we will just print out a warning or an information, obviously. And here if we exceed the number of coils available, actually it should have been here the byte location and not the coil out block size. Right now I've noticed this. Okay, and we're basically printing the illegal data address and setting the payload to the error, and then assigning the error to the response payload. Okay, let me show you the content of the glued Modbus write coil. So if you go to it, we're basically checking if we go past the block size, and then we basically add the 1 value or we reset it based on the bit position. So if I go back, the bit we will basically pass the bit position. So that's basically it. I will connect the board to the computer, and the buffer that we are going to write into will be this one, Modbus coil out memory. I've declared it over here with the size of 128, and let's run the board. And okay, actually we're getting an error. Yeah, basically it should be declared above that. So I will basically paste it here and I'll run it. Now we're getting no errors. I will open the Modmaster software that we will be using along this series. Then I'll run, and then I'll have to connect to the board using its IP. I'm using the same IP from the previous video, which is 192.168.137.022, and the port 502. Now let's say I want to write to, actually I have to, to set the function code to 05, and then I have to write, let's say, to 23 in our case. And then I want to write only one coil with the address of 1, and let's connect. Oh, actually I have to set it to TCP mode. I will connect. Actually I need to open the bus monitor to show you how exactly will the commands look like. So then I will basically write, and values are written correctly. And if we start to debug the payload themselves, you can see that they are basically signed properly. We have here the FF and the 00, meaning that we have to set the respective coil to the value of 1. And let me pause the program and check the content of the coil out mem, and this is the one that we're using. And you can see that the one is shifted to the 6th position because I have written here the address 23, but it is sent, the value that is actually sent over the network is 23 minus 1, so it starts basically from 0. Okay, now let me show you how we will write multiple coils, and the function code will be, let me see, the function code is 15. This is the function. Basically we're doing almost the same thing, retrieving the byte start and the byte location, and then with the bit position in the coil memory, and then we have to copy the response with the length of the coils, and then basically we're checking if you're going over the coil block size, and here we're checking if it's greater than 1968. And then here is the algorithm for writing the data into the coil. Basically we will do it for every coil that we have to write data into. Let me show you the buffer start index. The buffer start index, basically it's equal to 13, because let me show you the content of the payload itself, that this is the one that we're looking for, to write multiple discrete pins. And if you're paying attention to this, it will be basically the index 13 over here. So basically the coil values will be stored over here, and then that's why we need to start from the index number 13, and we'll basically shift it to the shift index. The shift index is basically set to the 0. So basically we will start verifying if the bits in the buffer start index are equal to 0 or not, and then if it's equal to 1 we'll set the coil, and then if it's equal to 0 we'll set it to 0. If you're wondering how do we calculate the bit position, well, the bit position is actually calculated first by retrieving the first bit position, and then we'll start to simply increment it. If we hit number 8, meaning that we've written till the end of the coil block size, which is 1 byte, then we have to reset it to 0, meaning that we have to start from the next byte. So I will debug the board again. I will open command master. I will set the IP again. Then I'll set the mode to TCP. I'll write to multiple coils. Let's say I want to start from address, let's say 30, and then we want to write 5 coils, and the value we want to write will be 11101. And before doing this, I will actually explain you what I'm doing over here. So if we have this, and this is basically the content of the coil memory. So basically the coil ordering is the opposite, meaning that the first coil will be 1, and then this one will be the second, and then this one will be the third that we're going to write. But in the memory it will be starting from right to left, as I told you. So it will be, the first coil will be this one, then the second one will be this one, and so on. So basically I said here the start address will be 30. 30 is equal to 24 plus 6, so basically it will be 3 bytes, and then the 6th index, And actually, if it's sent -1, it will be 50 index, so it'll be this bit. We start writing from this bit. So we'll set this bit to 1, then the next bit will be set to 1, and so on. Okay, so I'll go back to the code. I will connect, and then I'll open the bus monitor. I will write the data, values are written correctly, and also I will pause the program and show you the content. So this is the content, E0 and OX2. So let me check the content in binary. So basically we have one, I'll open them again, and we have here, starting from 5th index, we'll have 111, and then we have to the next, we'll have 01. As you can see, exactly the other way around. And also, if you want to see the error checking mechanism, I have over here. So let's say I want to write more than 1968 coils. So over here, if I'm trying to write more than 1968, I will get an error, meaning the illegal data address. No, actually should have been illegal data address here too, because I'm trying to write past the block address. So I will reflash the program, I'll run it, then I'll open the bus monitor actually, and I'll disconnect for now. Let's say I want to write to the address 1970, and I don't know if it will be simply something random, and then I connect, and then I'll write. As you can see, it says here illegal data address. Also, if you're interested in learning more about embedded systems, I have a free school community about this field. You can join there and ask your questions related to anything. We also have free webinars on this, and I'll see you later.